In this video, we are going to discuss students' t distribution. Here we shall have a brief idea about what is students' t distribution. The students' t distribution is used in testing of hypothesis in small samples because when the sample size is small, then the sampling distribution of the statistic may not follow the normal distribution. Therefore, we do not use normal distribution there. Instead, we use students' t distribution. Because when the sample size is small, then the sampling distribution of the sample statistic follows t distribution approximately. It does not follow the normal distribution. Therefore, there we use students' t distribution. So let's discuss what is students' t distribution. So random variable t is set to follow students' t distribution or simply t distribution if its probability density function is given by this ft equal to 1 upon root nu beta nu by 2 1 by 2 into 1 plus t square by nu to the power minus nu plus 1 by 2, where t varies from minus infinity to infinity. Here this symbol nu denotes the number of degrees of freedom, which I will discuss later on. And this distribution also assumes that the population from where the samples are drawn is normal. Now we look at the graph of this t distribution. So if we look at the graph, we find that the shape of the curve depends on the degrees of freedom. So here we see that for smaller values of degrees of freedom, the curve is more flat than the normal curve. That means for smaller degrees of freedom, the flatness is more. As we increase the degrees of freedom, we see that the flatness of the curve reduces. So here is the curve. Here we can see for nu equal to 3, the curve is a flat curve. The flatness is more. For nu equal to 5, the curve is less flat than the curve for nu equal to 3. And for higher values of degrees of freedom, the curve is approximately normal distribution. Therefore, for small samples, shape of the curve is dependent on degrees of freedom. That's why area under the curve for this t distribution is tabulated for various degrees of freedom in a table. That table is called t distribution table, which we will see later on. The definitions of rejection region, acceptance region, level of significance, critical values will remain same for the t distribution also. But here the calculation of area is different because the area will depend on the degrees of freedom. Now what is degrees of freedom? So degrees of freedom is the maximum number of logically independent values. That means how many values can we choose independently to compute or calculate a given sample statistic. For example, if you want to find mean of 5 numbers x1, x2 up to x5, then we are free to choose these 5 numbers. So there is no restriction on finding the mean. We can choose any 5 numbers and find the mean. But if we fix the mean as 35, then we are not free to choose all 5 numbers independently. We can choose at the most 4 numbers independently if number must be such that the mean is 35. So degrees of freedom in that case will be 5 minus 1 equal to 4. Similarly, if we want to find the variance of the distribution, we see that variance depends on the mean. So here we use one restriction to find the variance. Therefore, the degrees of freedom for s square will become n minus 1. So this is how we calculate degrees of freedom. The more is the number of constants, the more less is the degrees of freedom. Now properties of t distribution, if you look at the graph of t distribution, we see that the probability curve is similar to the standard normal curve, but it is more flat depending on the number of degrees of freedom, and it is symmetrical about t equal to 0, bell shaped and asymptotic to t axis. The flatness depends on the degrees of freedom. For large values of nu, t distribution tends to become a normal distribution. We have seen it. The mean of the t distribution is 0 because it is symmetrical about the line t equal to 0. The variance of t distribution is nu upon nu minus 2 for degrees of freedom greater than 2, and it tends to become 1 as nu tends to infinity. That clearly means that as degrees of freedom tends to infinity, the t distribution tends to become a normal curve. In fact, it becomes a standard normal curve with variance 1 and mean 0. Now how to find the critical values of t using t table corresponding to a given degree of freedom at a given level of significance can be obtained using the table like this. So table has been given for either right tail test or two tail test. The critical value t nu alpha for one tail test right or left, whichever is required, at level of significance alpha. This is same as the critical value of t at the same degrees of freedom at 2 alpha level of significance in two-tailed test. So look at this table. In this table, we have been given the top row as level of significance for two-tailed test. So these are the level of significance for two-tailed test, and this is level of significance for right-tailed test. So these values have been given for level of significance for one-tailed test. So these are the values for one-tailed test. If we want to find values for two-tailed test, then we have to just double the level of significance. For example, if somebody asks you what is the critical value of t at 10 degrees of freedom at 0.05 level of significance for right-tailed test. So this value is immediately here, 1.8126. This value is 1.8124. This value is 1.8124. This is for right-tailed test at level of significance 5%. And this is same as the critical value of t at 10 degrees of freedom at 10% level of significance. That means t10 at 0.10. This value is same as 8124. This table is for right-tailed test at given degrees of freedom at given level of significance. T nu alpha for right-tailed test is same as T nu 2 alpha for two-tailed test. So these two values are equal in the table. This is for two-tailed test. Here I have written this T nu for at 2 alpha for two-tailed test is same as T nu alpha for right-tailed test. So this table can be used for both one-tailed and two-tailed test. So here in this table, on the leftmost column, we have been given degrees of freedom, and topmost rows denote the level of significance. So this row will denote level of significance for two-tailed test, and this row will denote level of significance for one-tailed test, either left or right. So these are the positive values. That's why these values are on the right. So if you want to find for left-tailed test, for example, so if somebody asks what is the critical value of t at 10 degrees of freedom at 1% level of significance for left-tailed test. So this is the 10 degrees of freedom, and this is 1% level of significance for right-tailed test. So this value 2.7637, 2.7638. So this is for right-tailed test, and if we put negative sign, then this will become for left-tailed test. So if we put minus sign to these values, these will become critical values for left-tailed test. So table will be given for degrees of freedom up to 29. These tables you can find in any good book of statistics. So this was brief introduction to students' t distribution. I hope you understood. Thank you very much.